Hello everybody. Today we are working on lesson 41. It is the rate of change and slope. So I think the first thing that we need to cover here is the definition of a rate of change. So let's get into that. A rate of change is defined as a ratio that compares the change in one quantity with the change in another. So a great example of this would be the speed of a car because it compares distance to time. It's two different things that you're measuring, but you are comparing them and creating a ratio out of it, like 60 miles per hour. Okay, so let's jump right into it with an example here. Let me grab my example. Here we go. So, this example says a car travels on the highway at a constant speed. The graph shows the relationship between the distance traveled and the time traveled. Okay, so if we look over here on our graph, we've got the distance traveled and the time traveled. That's the two things we're comparing. Okay, we want to find the rate of change between these two measurements. So, for this case, the rate of change, we are comparing the change in distance. So let's write this down. Change in distance over the change in time, because that is the two different measurements that we are comparing. So, looking at our graph, change in distance. Well, this side over here is distance, so we need to look at the second number, the y value. So I'm going to do 120 minus 60 so that I get positive numbers. It's a little easier on yourself. Okay, change in distance. So it went from 60 to 120. There we go. Divided by, now since we took 120 first, we have to take the 2 hours as well, minus the 1 hour that went with the 60 miles. So now all that's left to do is solve. 120 minus 60 gets us 60. 2 minus 1 gets us 1. So our rate of change here is 60 miles per hour. There you have it. Okay, so that is how we do rate of change if you are given a graph. Let's talk about what that would look like if you had a table. So let me pull up this table here, maybe. Make it a little bigger for us. Okay. Determining rate of change from a table. So the shop fee for renting kayaks, the shop charges a fee for renting kayaks. We want to know the rate of change of that fee. So we're going to take the cost, the change in cost, divided by the time, or over the time. So let's make it easy. Let's take $60.50 for our first cost and subtract $32.50 for the second cost. Then we're going to take all of that divided by 4 hours minus the 2 hours for the $32.50. If we subtract $60.50 minus $32.50, will get us $28. 4 minus 2 will leave us with 2 hours. So the rate of change here is $14 per hour. And there we go. That is it for rate of change. Now, let's talk about slope. The slope of a line is a rate of change. What we need to know about slope is that it is comparing the vertical change of a graph to the horizontal change. So, what you will hear a lot of the time is people say slope equals rise over run. So what this means is the change in the vertical, so you're going to count how many blocks the graph moves up or down over the change in how many units the graph moves left or right. Rise is up and down, run is left to right. So let's get our example back up here and try this out. Alright, up here we've got determining the slope from a graph. So we're going to find the slope of graph A first. What we do is we're going to start at the lower point. Well, we're going to start at the point that's closest to this center line here. So we start at 0, -1. We're going to look at the rise. So we have to go up 1, 2 to be even with this 0.41 over here. So the rise is 2. Then we're going to look at the change in the left to right movement, so the run. To get over to this 4,1 point, we have to go over 1, 2, 3, 4. So the run is 4. Slope is rise over run. So the slope of this is 2 over 4, which is actually 1/2. So the slope of A is 1/2. Now, notice this line goes up to the right. The numbers are going to keep getting bigger and bigger. Okay, let's look at graph B. Well, graph B, instead of going up to the right, goes down to the right. So these numbers are going to keep getting lower and lower as it goes this way, right? So let's start at the point closest to the center. So here's this 1, 1 for us. Notice this graph, every block represents 2. So this is 2, 4, 6, 8. So to get from this 1, 1 down to 4, -8, we have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. So our rise is 9. But this doesn't go up, it actually goes down. So since the rise is down instead of up, we're going to put a -9. Now let's look at the run. So to get from this point over to this 4, 8, we have to go over 1, 2, 3. So the run is 3. -9 over 3 is just -3. So the slope of graph B is -3. Okay, there are a couple of special cases in slope. So let's take a look at those. These would be horizontal and vertical lines. So, horizontal line runs left and right. So it never goes up, so it never has a rise. So if slope is rise over run, this one is always going to be 0 over whatever the run is. Well, 0 divided by anything is just 0. So the slope of a horizontal line is always 0. No matter what. If it's a horizontal line, your slope should be 0. Okay, let's take a look at a vertical line. Well, what do we know about a vertical line? Vertical lines go up and down. They never move left and right. They're just straight up and down. So that means it's always going to be whatever the rise is divided by 0, because it's never going to move left and right. Well, you can't actually divide by 0. So there's really not an answer to this. The word we use is undefined. So the slope of a vertical line is always undefined. Okay, so knowing that, let's test it out. Okay, so this first example, part A, says find the slope of the horizontal line. So I know this is a special case. We don't even need to try to calculate anything. We're going to go up here. Horizontal line, the slope is always 0. So I automatically know the slope for A is 0. Now, example for part B says find the slope of a vertical line. Well, again, it's a special case. Go up to my notes. The vertical line is always undefined. So my slope on this one, I'm just going to write undefined. That's it. You don't have to do any kind of calculations for those two cases. You just always know that that is true, as horizontal line is 0, vertical line is undefined. And that is the last bit of new information that I have for this lesson. So make sure we're getting the homework done, and I will see you in class.